Hi, we are Astral Orbit, the rocket team from Marquette High School in Chesterfield, Missouri. We love working together to build new things. So when we learned about TechRise, we were thrilled to submit a proposal and even more excited when we found out that we got in. The primary goal of our experiment is to study lunar regolith, also known as moon dust. Lunar regolith is extremely problematic for moon missions because the particles are small, electrostatic, sharp, and they float along the surface until they hit something and stick to it, just like one of our spacecraft. Even on the Apollo missions, which only stayed on the moon for less than a day, the regolith wreaked havoc. It covered visors, got into capsules, and damaged instruments. If we want to stay on the moon for weeks, months, and even years, we need to find a better solution for mitigating lunar regolith.
For this experiment, we are going to be testing the cohesiveness and adhesiveness of regolith. That means that we are going to be checking how regolith will stick to itself and how it will stick to other materials. In the end, we chose NASA, who provided us with these two regoliths. We were able to choose the LHS-1 due to the fact that it is the most similar to the lunar regolith that is going to be found at the South Pole.
Our experiment works by utilizing the unique spin stabilization launch profile of the UP Aerospace Space Loft launch vehicle. The chamber is designed with a series of angled plates, similar to those you find in a washing machine, but instead of dealing with clothes, dealing with moon dust. These plates will force the regolith into contact with them exactly where we want them to, at exactly the time that we want them to be in contact. Now with this footage, our avionics team will be able to analyze it.
So to aid in the data collection and analyzation of regolith, we actually formed a programming and avionics team. And so what we're currently doing is we're trying to find ways to route data from the UP Aerospace flight computer to our microcontroller. And we're going to be saving that data for later for processing, and we're going to be analyzing it just to quantify our understanding of regolith and microgravity. And so another thing we're also doing is we're adding a camera feed inside of the tube just to take a look at how regolith is actually moving in space. And so this camera feed and the raw data that we collect is all going to be used to further our understanding of regolith's behavior in microgravity. Over the course of NASA TechRise, I've actually deepened my understanding and love of computer science. And so I've learned a lot of new languages and I've learned a lot of new coding techniques.
One way that this project has helped me deepen my understanding of code is that it helps me figure out how coding and actual electronics work together. Before this, I never really put code onto a microcontroller. So now that I'm doing that, it's a new experience for me and it's helped me deepen my understanding of how code and mechanics can work together to create a full functioning model.
So this is the most recent version of our prototype and is the vast majority of the features that will be used in the final version. So we got the redesigned chamber to be lighter and have pressure outlet ports. In there you can see the different plates for various materials, and there's little slots for them to slide into. On there you can see there's a little slot for an O-ring to go into. Everything threads into the same screws. And then it mounts down here to the experimental box.
However, there is still a lot of work to do. Before we can launch our experiment into space, we need to finalize our spin profile and how it works with regolith, our cameras and their lighting setup, as well as our coding. What we found most exciting about this opportunity is the chance to actually contribute to meaningful and valuable research. Our findings could help humans go back to the moon, this time to stay. We have a special thanks to NASA and future engineers for making this all possible, for funding our ride to space and our experiment, and for helping us with our experiment construction. Thank you.